Hello class, let's tackle this SAT problem. It's a word problem, which means our first job is to translate the sentence into a math equation. The question states, the sum of two consecutive integers is 75. What is the value of the smaller integer? Let's break it down step by step. Alright, let's look at step 1. The key phrase here is consecutive integers. This just means numbers that follow each other in order, like 7 and 8, or 20 and 21. The difference between them is always 1. In algebra, we use variables to represent unknown numbers. So as you see on the screen, we'll call the smaller integer nen. Since the next integer is just 1 more than that, we can represent the larger integer as n plus 1. This is the most important first step to setting up our problem correctly. Now for step 2. The problem tells us that the sum of our two integers is 75. The word sum means we need to add them together. We take our smaller integer, which is n, and we add our larger integer, which is n plus 1. We set the total equal to 75. This gives us the simple equation you see on your screen. N plus, in parentheses, n plus 1 equals 75. Now that we have our equation, we can move on to solving it. Okay, on to step 3, where we solve for n. Let's look at the left side of the equation, n plus the quantity n plus 1. We have two n terms here. We call these like terms, which means we can combine them through addition. So n plus n gives us 2n. The plus 1 just stays there. This simplifies our equation to what you see now. 2n plus 1 equals 75. This looks much easier to work with. We're continuing our mission to solve for n. The goal is to get nin all by itself. Right now, we have 2n plus 1. To get rid of that plus 1, we need to do the opposite operation, which is to subtract 1. A golden rule of algebra is that you must do the same thing to both sides of the equation to keep it balanced. So we subtract 1 from the left, and we subtract 1 from the right. On the left, 1 minus 1 is 0, so we are left with just 2n. On the right, 75 minus 1 is 74. This gives us the new, simpler equation. 2n equals 74. This is the last part of solving for nen. Our equation is 2n equals 74. Remember, 2n means 2 times n. To undo the multiplication, we do the opposite. We divide. We need to divide both sides by 2 to get n alone. On the left side, the 2's cancel out, leaving just nen. On the right side, we have 74 divided by 2, which is 37. And there we have it. We found that n equals 37. Excellent! We found that n equals 37. But let's not rush to the answer just yet. In step 4, we must always check two things. What does n represent, and have we answered the question? We defined n as the smaller integer at the very beginning. The question asks for the value of the smaller integer. So our answer is 37. As you can see on the screen, we can do a quick verification. If the smaller integer is 37, the next one must be 38. Let's add them. 37 plus 38 equals 75. It matches the problem statement, so we know our answer is correct. So for our conclusion in step 5, we can state with confidence that the smaller integer is 37. The final part of any multiple choice question is to match our result to one of the options. Looking back at the question, we can see that our answer of 37 matches option C. And that brings us to our final result. The correct option is C37. We successfully translated a word problem into an algebraic equation, solved for the variable, and verified our answer. This is a fundamental skill for the SAT, so be sure to practice it. Well done, and I'll see you in the next lecture.